talking about basic graphics one more time. Hopefully you've brought some questions with you this time. You've maybe experimented with it, at least some of you have, and we can do something of that nature. The next class will be a review for our first test. Okay, so I try to guide reviews by your questions. So you tried to stump me. But if you don't come up with anything, I'll just sort of walk through the slides again, something like that. But it's better if you can bring questions. It will help your learning experience, I think. We will have a lab this Friday based on basic graphics. So you will try to create a small game and you'll be given step-by-step instructions. Any questions before we begin? All sound great? All right, let's see, where were we? All right. You know what? I really wish I could make this go away. This one. Okay, great. Great. All right. Okay, so let's see. So I have a Mars lander. That's the thing you're going to make. I guess I could show it to you running. I'm not going to show you the code because, you know, I'd like you to work through that yourself. But here is the game that you're going to build. Give it a second to start up. Okay, so it looks kind of like this. And if I press the arrow key, right, it accelerates upward. And my goal is to get over to that landing pad and land on it while not going too fast in either the X or the Y direction. And I often can't do it. Ah, X velocity was too large. Oh, well. Once again, I'm dead. All right. So that's how the game looks. Very exciting, but you will all build that. All right. Let's see, what else have we got here? So first question is, are there any of the examples that we've already done that you'd like to see again? That you'd like to go over in a little more detail? Nothing. No questions. Yes, JJ. Yeah, so let's go back to the flyer. So yesterday or the day before, I can't remember, I fixed the problem I had, the thing that I broke in Basic Flyer. So I have something new I want to show you there anyway. So you need to get a new version of Basic Graphics for this, but anyway, let me show you this. Okay, so if we go to the Basic Flyer code, then there are these lines that are commented out here. So one of the things you can do, right, with the scenes is you can set a background size. Now, what I'm going to do is I'm going to set the background size to something that is much bigger than my actual screen. And I just do it in the scene. And what that's going to accomplish, let's take a look at what that does. Okay, when I run that, so this part's the same. But now, look, remember the borders on the right and left-hand side? Now I'm going to go fly through this border. And poof, I jump to the other border. The other border is actually kind of far away. I can see it if I fly over to it, or I can fly sort of the long way around. And there's the other border. And if I go down, I can find the other one. All right. And then it crashes into that one and pops on the top. Okay, so that's how that works. So There's actually two things that have to, less talking, please. There's actually two things that you need to have to make that happen, right? So you have to set the background size to something large, and you have to set the focus. The focus is the sprite that is the focus of the scene. So it's going to try to keep that one close to the center. Now, another thing that you could do is you can set periodic, and you can do it either X and Y. I'm going to switch both of them. So what periodic is going to do is, instead of what the behavior you saw where it was jumping, so it would hit the border and jump to the next part, we're just going to scroll as if the whole world were round. So I can go across the borders this way. Yeah. Yeah, that was not hard. That was not particularly easy to code, but I did it. So, all right. I know. Thank you. Thank you so much. Yes, Scott.
So with it being a big background that kind of scales, could you change the size of the screen without it affecting?
It should. Let's try it. You're testing something I didn't think to test, which is usually a danger sign. Oh, look, it's working fine. Look at that.
That's how you could set it to work with multiple screens.
Yeah. So I was thinking with a little modification, I could also make it work if you set the background size to smaller than the screen, and then you'd see replication. But I don't know that we have a use for that. But I could make that happen too. All right. And you notice every so often it will pause. I think that's because Java decides to do garbage collecting. All right. So those are two new capabilities. That is sort of a set of new capabilities that you have, which was supposed to be in there from the beginning, but I had accidentally broken them. So any questions on that? JJ. Yep, right. So the idea is, you saw when I didn't have periodic on, what happened was when I collided with a boundary, we didn't scroll past the boundary. The boundary remained the edge of the screen. So I try to keep the focus sprite in the center, but when it gets to the edge of the screen, it stops being in the center, right? So let's just view that again. So this one, it always stayed right in the middle, and the world just sort of reshaped around it. But in this one, well, let's just change one of them. Okay. So I'm periodic in the Y direction, but not the X. Okay, so in the X direction, right, I'm not periodic necessarily. Well, I'm not periodic because, and so if I get near the border, then I might stop being in the center, right? But if I hit the border, then I jump, right? So this way I'm periodic in the Y direction, and I can fly in the Y direction, but if I hit the X borders, it behaves differently. And I drew the borders on the background of this. I mean, it's kind of funky to have the borders on here, but I drew the borders on here just so you could see what was happening, right? I mean, if you were making a real space game, you probably wouldn't draw the borders, and it would just look like you had infinite space or something. But I drew them in so that you could see what was happening. Okay. Any other questions? All right. Yes, Ty. The sprites can live anywhere in the background, and only the ones that are in the visible window will be drawn. But the other ones are still there, and they're moving around even if you can't see them. That you might hear them if they blow up. I don't know. All right. Other questions? All right. So JJ, you'd wanted to see stuff about the basic flyer, and I just sort of hijacked everything.
I just wanted to go and visit back about how like the Falcon moves, how like you update its location and stuff?
Yeah, okay. So what you do, the way you handle sprites, right, is you don't move them usually. I mean, you can, right? You could just you could set a clock worker and you could update its position every clock cycle. But by default, what you do is you set velocity, and velocity has an X and a Y component. And that component just sort of stays. Let's see where Falcon. So if I go to the top of the Falcon class, right, I set vel to 2 constants, right? So it's moving to the right. It's got a positive x velocity, and a 0 y velocity. Yes, Ty. Yes, that's a good thing to call me on. So there is a thing in the sprite, and I have to double check and make sure I put this in the instructions for the game, because you notice the sprite didn't do that kind of thing. There is a property in the sprite, freeze orientation. Okay, so if you set your freeze orientation on your sprite, then when you reverse velocity, it won't turn upside down. So it'll just sort of stay the way it is and move in random directions. So you can freeze the orientation. By default, it's going to try to orient itself to the direction it's moving. Yeah. Okay, well, you'd have to show me that because it should have flipped, right? So when you change the velocity, it's going to try to follow the direction unless you have that freeze orientation set. That's the behavior that's supposed to be there. Now, nobody writes bug-free code. I have this little speech I like to give at some point during the course, and it's kind of so the point is, right, at this point you've all hopefully written enough code to realize how easy it is to fool yourself and make mistakes and write code that doesn't work the way you intended, right? And think about this. Usually, very often, at least in my case, I've written, programs that are even like 10, 15 lines long, and it still did something that I didn't expect, right? And this is despite the fact that programs are completely logical. I know everything about it because I created it. It's completely deterministic, right? And so you come to realize that if you don't test things, you don't know them. But I'm willing to bet that especially today, all of you have political opinions. Maybe some of you don't. I don't know. But generally, you have political opinions. Somebody was the best president. Somebody was the worst president. And these are all things about which you don't know all the facts. They aren't logical. They aren't deterministic. And almost all the information that you've gotten comes from somebody who's trying to persuade you to believe a certain thing. And yet, you will be confident that you know something is true about politics, and you shouldn't ever be, right? Because this should prove to you that you can't know that, right? So I want to train you to think like scientists. I want to train you to doubt when you don't know the information. And you still have to make a choice, right? Whether you're going to vote or who you're going to vote for, but you need to appreciate how little you know. And this is something I often think about. If you were living in Germany in 1930s and the thing that you wanted to see happen was Israel get a homeland, the ideal candidate would have been Hitler, because that's what caused that, right? So sometimes the bad thing brings about the good thing, and you have no way of knowing that, right, ahead of time. So it's just another component to how little you know about the way things behave. So sometimes the thing that looks the worst is the worst, but very often you're just fooling yourself into thinking you know something. So keep that in mind. And if you're tempted to put something incendiary on social media, remember that you really don't know. All right. It's very hard, though. It's very hard to convince yourself you really don't know political opinion. Your political opinions are hogwash. All right. Let's see. There is, what haven't I shown you? I have a program that I made called Langton's Ant. It's not really a game. It's a computer science description thing that I just sort of coded and used basic graphics to help me visualize it. It's an ant that crawls across a grid and makes a pattern. And is it not starting? Did I break it? Let's try again. There we go. That's, you can't, it's moving too quickly, but that's a little image of an ant. And that's the pattern it makes. It's called Langton's Ant. I think I just call it ant in here. Langton's Ant, there we go. And I have an ant sprite, and the ant sprite loads a picture. It loads a picture. A little less talking, please. A little less talking, please. It loads a picture. It sets some constants. Oh, it's got a do move. So this one, instead of relying on, so normally what you do when you want your sprites to move is you set the velocity and the system moves them for you. And when you want to know if they collide, you create a collision listener, a sprite collision listener, and it tells you when that happens. This one, I did something different because the Langton's Ant needs to do some different stuff. So I did a calculation of direction and position based on the formula. So it's got some detailed calculations that I do here. And then the ant, which I don't remember exactly how they work. I'd have to look up the algorithm again. Here, I set constants. Now, it's always useful to set constants for yourself as final statics, usually somewhere near the top of a class, because what's going to happen is you're going to want to configure your class later or change its behavior. And if you can just change a constant somewhere at the top of a class rather than 10 places throughout all your code, it's going to make your code better. So we have a basic frame. We have a sprite component. We have a paint background method, which, yeah, okay. We have a new sprite component that we have an anonymous inner class where we overrode the paint background method. You can do that as opposed to setting a painter. This is sort of an old way of doing things. And it's not what I do any longer normally. I like to set that on the sprite. So I create the ant, and I don't do anything with the ant, right? Because I don't save the result of the, yes, Scott. Yes. So the question is, if you're building a maze, would the walls be sprites? Generally, that's what you would do. You would make the walls into sprites, and then you could detect collisions with them. That's kind of what I did with the Mars lander, right? So the landing pad is a sprite that's just a block that sits there, and you use a collision listener to detect it. There might be other ways you could do that. You might be able to sample pixels from the background at the location of your character and make decisions according to that. But that is the intent, is that you would use you would make the walls sprites. The ant sprite, as I say, I don't save it anywhere, because if I just instantiate it, it will show up on the scene, and that's all I care about. I did a string layout. Oh, one other thing is there is a method on basic frame and basic container called set singleton layout now, right? So if you just want one component for your card or your screen, you want it to fill the whole screen, you can just use that. All right. Okay, and then this has the normal things in it. Set the preferred size, add the move sprites task, initialize with a speed, and show. So if I put the speed at something slower, say 50 instead of 5, right? Because larger is slower. Man, it's warm in here today. I keep having to wipe sweat off my nose. Now you can see the ant. It's not just a blur. All right. Anyway, that's a very simple thing. When I did my sprite, did my sprite, I had to draw a grid, and I did it by drawing a bunch of rectangles at regular intervals. I could have drawn lines, but I drew rectangles. Any questions on any of that? Yes, Serene. This is drawing something specific. So the algorithm for Langton's ant, which you can look up, the ant has certain rules by which it moves. And it creates something that looks kind of organic and random, but it's deterministic. And then I have a game that a student made for me, a graduate student made for me, Lights Out, which I'm not good at. There's a theme here. I'm not good at any of these games. I guess I didn't click this. So you click these squares and you try to turn them all off. Or on, I forget which. Yeah. I'm just really doing it at random here, I guess. Yay. Yeah, the lights are all on. Now I guess I need to turn them off. So you got to help me. Ha! All right. So this has got two things. It's got a tile. It's got a tile and the lights out. So it's got a sprite component. It's got a singleton layout, right, that I told you about. So it's just going to have that one sprite component occupying the whole thing. It creates an array of tiles. Each tile is a sprite. Okay, so it's detecting the when you click on it. And the sprite has a picture that's just going to be a black or white square that it can change. So start lit, and start lit, I guess, gets set externally. So this one, they have these various methods to toggle the neighbors. Oh, here's the picture, make tile with a Boolean lit. So that's going to, what this is going to do, right, is it's going to do the same thing that we always do with the ball. So it's going to create an image of size, tile size by tile size. It's going to get the graphics object. It's going to set the color to red. It does a fill rect. And then based on lit, it does a color, it selects color black or white, and then it fills rect. So for some reason, it first draws a red square before it draws a white or black. That's weird. That code shouldn't actually need to be there. That shouldn't matter, right? Oh, I see why it's there. Because what he did, I just noticed what he did when he draws the black or the white, he leaves a size 1 border all the way around. So he gets a border of red around each tile. So that's why the red is there. Could have drawn a red rectangle without filling it, but that's the way it was done. Any questions about that? Okay, so these are all very small games, right? And yours is going to need to be bigger. You're going to need to get up to 1,000 lines. And kind of the way that you can get up to 1,000 lines is you can have a bunch of different special cases. You pick something simple to start with, you know, maybe your Flappy Bird, and then the Flappy Bird maybe faces weird obstacles and he has to get food and get out of cages and so on. If you add up enough different features, your game becomes kind of interesting and different, and you can get up to 1,000 lines that way, hopefully by the end of the course. And it will happen that you'll do your first lab for your first step toward this, I think, on the 14th. Yes. So you have your first final project assignment on February 14th, where you will try to get your code up to 100 lines. Now, at 100 lines, you know, you're barely doing more than anything I've already shown you. You're taking a basic shooter and maybe changing colors almost. But the point is to get you started and to get you to making regular progress. So this should be easy, hopefully. All right. Questions? Yes. Name? Cody or Kobe? Okay. Yeah. Okay. So scenes and cards. So high level, right? You have a frame. That's the basic frame is where you start. And the basic frame has a layout. And the layouts can be cards. Okay. Within those cards, if you choose to use cards, you don't have to. You can just have one layout to rule them all on your frame. Within those cards or on the layout itself, you can have a sprite component. Now, scenes are kind of like cards for the sprite component, but it's hierarchically further down. Okay. So a scene is going to just affect the sprite component, and it's going to be a background plus a set of sprites. And when you want to change scenes, you move it, you provide one sprite that moves from the scene that you're on to the next scene. So the theory is, right, if you're making a dungeon game, first you have, say, your menu screens on the first card. Then you select the card where the game begins, and you have your first level. You go through your first level, whatever, you do things. You want to go down a staircase. That's a new scene, potentially. The second level is a scene. You can come back up to the first level, or you can keep going down. If you want to go switch to your inventory, that could be another card, right? Which would take you away from the sprite components and show you some, you know, numbers that you could set or something like that. And it would be on the sprite component, yes. So that's the basic flow of it. Questions? Scott.
So, especially with writing a bigger program, involving a bunch of different conditional methods, is there any limit to how many classes we can have to kind of separate and organize?
No, there is no limit. There's no limit to the number of classes you can have in your final project. I think I have a requirement that everything has to fit under 100 megabytes, but I don't. The only way people go over that is when they put, you know, these huge sound files in. Okay, let's stop here and take our quiz. Yay.